Welcome to lecture series 8051 microcontroller. In the last sessions we have discussed about the instructions. So, based on the instructions in today's session we will discuss how to write some programs. Okay. So, among that how to find the addition of first natural 10 numbers, then average of n numbers, then can we find our own data is available in the database. So, that way we will discuss on today, and also how to declare the delay if the time is available we will discuss. Okay. So, among the instructions we have discussed what is data transfer instructions, what is arithmetic instructions, what is logical instructions along with the branching instructions. Okay. So, the data transfer is used to initialize the value, is used to access with memory, we can store, right. That kind of transferring will be performed by using the data transfer instructions. In arithmetic instructions we can use addition, subtraction, multiplication, divisions along with increment, decrement instructions we have discussed. These addition, subtraction, multiplication, division, one of the data should be loaded in accumulator, then another one in any one of the register. For addition, subtraction, for multiplication and division it should be in B, then it will process the resultant is stored in the accumulator. Okay. That is one of the advantage, that is why accumulator is called it as a special register. Okay. In logical instructions the same thing, one of the data should be loaded in accumulator, the remaining is loaded in either in register or memory, or immediate data you can initialize it. So, and or not functions along with the exclusive we are using, and also we can use the rotate instructions, rotate either left directions or to the right direction. What will happen, either the LSB will replace the MSB or MSB will replace the LSB. This is a normal rotation. The same rotation also you can use it with the carry. So, carry means what it will do, instead of passing from LSB to MSB we are passing to the carry flag. So, the LSB will replace the carry flag, the carry flag content will be enter into the MSB. So, this is a way with the carry we can rotate. Okay. The swap accumulator also available, which is to interchange the lower nipple with the higher nipple of accumulated data only. In the branching instructions we have discussed either conditional or unconditional. Unconditional means without checking any flags, it immediately switch over to the specified locations. During the switch over, the current content of the program counter will be loaded into the stack pointer, right. So, the new subprogram address will be loaded in the program counter. Now, the program counter will increase and execute the sequence of program. After reading the return instruction, now it will terminate the subprogram, it have to return to the main program. So, for that it will now pop the content which already stored in the or pushed in the stack. The popped content will be loaded into the program counter. Now, the program counter will continue the remaining instructions in the main program. Okay. So, this is a way. In conditional instruction means it will check the flags available in the program status word, whether the carry is occurred or not, whether 0 flag is occurred, set or reset. Okay. At the same time this 8051 is also bit addressable, right. You can check whether the bit is set or not. If the bit is set you can switch over, if it is not then you can continue your regular instructions. Okay. So, here two more instructions we will discuss on today. The one is suppose you are initializing any one of the counter, what we are doing, ask you to write the multiplication program without using multiplication instruction. So, what we are doing, we are using the consequent addition, okay, 25 into 17 I am asking you to write multiplication. What you will do, one of the data should be loaded in accumulator. So, a comma 25 I will do it. The another one what I will do, loaded in any one of the register or not I will take it. So, 17. So, what it indicates, the 25 is 17 times I am going to add it, right. So, during that time just I am okay. So, either you can initialize in the accumulator or you can use it in R1 register for consecutive addition. Okay. So, these two are the data initialization. Now, I am going to start the program. So, I will clear the accumulator. Now, what I will do, add a comma r1. So, what will happen? 0 plus 25 is added. Now, it is stored in the accumulator, which is 25. Okay. Then I have to decrease the counter, because this addition how many times means 17 times I have to add it. So, for after the single addition, now the 17 become 16, then again it become 15. So, that way I will use DEC or not. So, what will happen? The R naught will decrease, then I will check it based on the condition flag, which is jump on 0. Okay. So, if 0 means I have to exit. So, without 0, that is its reset means I have to continue the process. So, that is why I will take it as jump on no 0, then repeat. So, here it will repeat the process. Okay. So, till reach 0, the addition will continue. If the 0 it reach or not equal to 0 means it will exit from the loop. Now, we are available here. So, what it represents? Now, the result is available on the accumulator, then wherever you want you can store it. Suppose I ask you to store in R3 register means move R3 comma accumulator, then you can stop it by using the short jump instruction. Okay. So, what is a special in 8051 means, instead of using two different instructions, okay, by a single instruction we can perform the decrement operation. What it represents? So, instead of these two, okay, you can use decrease and jump. Okay. Here we are using the decrease instruction, then jump instruction. Instead of that, you can use decrease jump not equal to or not 0, then you have to give the register, then the label. So, by this also you can use it. Okay. So, this is one of the instruction, decrease jump not equal to. The same thing also you can do it by using the compare instruction, compare jump not equal to. So, compare register comma the given data, then label you can give it. Okay. So, what here I am giving, I am comparing with the 17. So, till reach the value of 17, I will compare R1 to 0. So, till reach the 0 value, the process will be repeated. So, okay. So, based on these two instructions, today we will discuss some example programs. Okay. So, now we will discuss addition of first 10 natural numbers. So, first 10 natural numbers you consider from 0 to 9. So, what I am planning to do is 0 plus 1 plus 2 plus 3 plus up to 9. Okay. So, for addition, first we have to initialize the register, which is the maximum count, move R1 comma 10. Okay. So, 10 numbers. Then I want to store the resultant in port 2. So, I want to initialize the first value, which is 0. First value I have initialized, then I am clearing the accumulator. Okay. So, these are the initialization process to perform the function. Now, I am going to initialize the loop. What is my aim? I have to add. So, add a comma or not. So, what will happen here? 0 0 plus 0 0 is added and the result is 0, right. Next, I want the number 1. So, for that, instead of calling the number 1, suppose we have a 10 different number means you can initialize the memory and you can call one by one. Okay. This is a natural number. So, the number is increased by 1 only, that is why I have planned to increase the use the INC instruction. So, INC R naught. Now, the R naught become, this is the accumulated value, this is R naught. Okay. Now, the R naught become 1. Then what represents, I have called the second number. So, I have to reduce the counter also. So, to call the next number, I have increased the R naught register. Now, I have to reduce the counter. Instead of using DEC and jump, I will use the same instruction, decrease and jump not equal to or not 0, R1 comma, that is label I have to do, you can do it the name as repeat. Now, the R naught value was increased. Now, it will check the R 1 is not equal to 0, here R 1, it is decreased from 10 to 9, accumulator value is 0 plus 1, now the result is 1. After that it will decrease, it is 8, so not equal to 0, it will repeat the process. Now, add with accumulator, accumulator value is 1, R naught value is 2, it will be 3, right. Then it will check, decrease the value R 1 which is 7, 7 is not equal to 0, then again it will do the process, accumulator value become 3, then R naught become 3, the value is 6. So, now it decreased to 6. So, the process is repeated till R 1 becomes 0. Whenever the R 1 reaches 0, it will exit from the loop. Now, the result is available in the accumulator. As per your requirement, you can store it in the port 2 of accumulator. Okay. Then you can stop the program, short jump here. So, I hope you get the idea how to add the first 10 natural numbers. So, initialize the maximum count value, then you continue. The same program you can extend up to 50. Suppose if you want to add the number up to 50 means just you replace this value as 50, no need to change anything in the program, just you replace it as a 50, then the same program is repeated up to getting the 50. So, the initial value become 50, 50 to 0 we are continue the loop. Okay. Now, we will discuss the next example. Suppose I am asking you to write a program to toggle the all the bits in port 2. Okay. So, the toggling the bits it will take 50 milliseconds. Okay. For every 50 milliseconds I want to toggle the flip flops or bit positions. Okay. Suppose you have the port 2 value was 45, or you can take it as alternative bits to toggle or any bits. Suppose okay, you will take the value as 0 0, right. So, this all values of 0 0 should be toggled for every 50 milliseconds. Okay. So, what is our aim? I have to initialize the value first, right. Move a comma the initial value 0 0 h. Okay. So, port 2, so I will move the value accumulator to port 2 comma a, right. So, what it represents, the accumulator value is moved to the port 2 of 8051. So, here suppose I have connected with the LED means the corresponding LEDs will be glow. Now, what I ask, it should be maintained for the 50 milliseconds. So, I have to call delay. Okay. Then after that what I want to complement this. Okay. So, I will use the CPL A. CPL A means now the value in the accumulator become FF after the complement. Now, I will move this data into accumulator, or I can repeat the same process, short jump. So, first I display the value 0 0, then I called the delay for 50 millisecond, then I complement. Now, this bit position become FF. So, initially the value 0 0, all LEDs are in off condition. Now, complemented, all bit positions become on. So, now the LED, after that after complementing, now we are switch over to this position. Now, the accumulator value is passed to the P2, now only the all the LEDs become on, right. Then after 50 milliseconds I am complementing, so it become 0 0. So, 0 0 means again I am pausing, now the 0 0 will be passed to port 2 which will goes to off. So, like this the same process complementing and pausing which will on and off the LEDs. Okay. So, now I have to think how to initialize 50 milliseconds delay. Okay. How to write the delay program. In the last sessions itself we have discussed how to declare the delay. So, whatever the system clock frequency, right, that will be divided by 12. then whatever you are getting, that will be considered as your clock frequency. So, we are considering the frequency as 11.0592. So, after that value, so by using this frequency you can calculate the time, which will get it as a 1.085 microsecond. So, directly you can calculate it, what is your required time delay, 50 millisecond divided by 1.085 microseconds. So, in the previous sessions we clearly specified how to calculate the delay. Okay. So, based on that you directly take your required time divided by 1.085 microseconds. So, after dividing you get the value as 46,082. Okay. So, this value should be subtracted because of 16-bit length. So, I will take it as 65536. Okay. So, after subtracting from this I will get the value as 19,454. This is the decimal equivalent. Okay. So, but in 8051 we are using the hexa equivalent. So, it should be converted into hexadecimal. So, after converting the hexadecimal I will get the value as 4B FEH. Okay. So, after getting its corresponding hexadecimal equivalent, now you can write the delay program. Okay. So, I will start to write the delay program. What suppose if you are taking the R2 and R3, then take move R2 comma FEH, then move R3 comma 4BH. Okay. Now, decrease and jump, not 0 R2 comma, the same line you can continue here. Then decrease jump, not 0 R3 here, because once the FE becomes 0 0, then you are getting the borrow, right. Then this value become FF, then FF will be reduced to 0. So, these two lines will be repeated till both bit get 0. Okay. So, this is a way you can declare the delay. So, to toggle all the flip flops we are taking this bit position. Suppose I am asking you to toggle alternate LEDs or alternate bit position, means you can take it as 10 10 10. So, in that case you can take it as AA, or you can start with 0 1, means what you get 5. Either this position will be replaced with the AAH or 55H. So, by using AAH or 55H, what will happen? The corresponding LEDs will be glow after passing through the port 2. Now, you are calling for 20 milliseconds. After complementing, the AA become 55, then the 55 will be glow on the LEDs. Okay. So, the same program, by changing the input you can give the alternate bits, or suppose only first 4 bits you want to switch on, means 0 if you can give it. Next, you can compare your own given number with the existing database. Okay. Suppose you have 5 numbers, among the 5 numbers you want to check whether your own number or required number is there or not. So, in that case how we are planning, means suppose I have the database which is 29 4B 62 okay, 14 and FA. So, these are the 5 hexadecimal number. Among this I want to check whether my data, suppose I want to check the data is 25, 25 is within the list or not. Okay. So, for that what we are doing means I have to initialize the memory for this, So, I will take it as R naught. Okay. So, R naught with the address of 30. So, move R naught comma 30H. what it represents, the 30 in the address 30, the 29 is stored, in 31 4b is stored, like that. Okay. So, how many numbers in your database will be initialized in the R1? So, R1 comma 5 numbers. So, 0 5 I will give it. Okay. So, first the initialization process is over. Now, I want to compare it. So, for comparing I have to move with the accumulator, right. So, move accumulator at R naught, the first data R naught, which is actually 29 in the accumulator. Okay. So, after that I want to decrease the counter, then increase the R naught for getting the next number, right. After that I am taking compare and jump not equal to what is your required data. Okay. So, accumulator content is compared with your own data 25. Then where to jump means, yes, jump to this position. So, what I am asking, the first number 29 is taken, right, 29 is taken, then decrease the counter as 4, okay. Then increase to R naught means it will take the next address 31, 31 content is 4b. Now, the 4b is compared with the now accumulated data, first is compared with the 29 is compared with 25, which is not equal, right. Now, I am calling the next number which is 4b, which is not equal. So, till getting the not equal, it will repeated the process, at the same time it will decrease the loop also, right. At the same time, suppose my third data is 25 means it will exit from the loop. So, once it exit from the loop means whatever you want you can do it. Suppose if any matching is found, I am asking you to display the value 0 1 in R3 register. Then what you will do, move R3 comma 0 1 H, or you can glow the LED, which is like only the particular bit position you want to switch on, then you can switch on set bit of port 2.7 or any bits you can switch on it. Okay. So, by this way you can understand which bit to be switch on, right. If the LED is on means you can find matches your given number is within the database, otherwise it is not matched with the existing data. Okay. Suppose if you want to find the average of 10 numbers, okay. Average of 10 numbers means I want to add any 10 numbers, then divided by 10. So, how we are writing is, first you want to declare the database to store the array value, right. Then take R1 comma counter 0a, because we have to give only the hexadecimal number, which is counter you can say up to 10 numbers. Okay. So, this same number average means 10 number is added, then divided by 10, that is why the division should be loaded in the B register. I will move the same number into B register. So, B comma R1, move A comma 0 0, right. Now, you add the value, add A comma at R naught. So, the first value is added, then you can increase the location to get the next number, then decrease and jump not equal to, jump on 0 with R1 comma R1 to repeat. Okay. So, this process is used to add the 10 numbers. So, after addition now the result is accumulator. So, simply you can use the instruction division, div AB. Okay. So, the accumulated value will be divided by B, which is stored in here, that is the R1 value. So, by this now the result is available in the accumulator and B register, then you can stop the program. Okay. So, for n number of data you can add it and divide by the same thing. Suppose I ask you to add only 5 numbers, up to 5 numbers means here you can change the value as 5 and you repeat the same process. because when reach the R1 value is 0 means it will exit. So, only it will add the first 5 numbers. Okay. So, in today's session we have discussed how to write the program by initializing the loop. Okay. The same instruction which is used to decrease and jump. Instead of 2 instructions we are using the single instruction. By using this we can reduce the number of emission cycles, which represents the, it will reduce the execution time. Okay. So, I think you have a clear understanding of how to write the program to find the average of n numbers, or how to find the matching of a given number, how to toggle the bits. Okay. Thank you.